Hi, in this video we want to talk about translation, composition, and graphs. So we want to discuss how does a graph change when we translate either the x variable, the independent variable, or the y variable, the dependent variable. So this translation is affected by just subtracting or adding a number. For example, you might have a function that looks like g of x is equal to x plus 2. So what does that do? It takes in the number x and it spits out that number plus 2. And what does this do geometrically? It takes a point on the number line and moves it over 2 units. It translates it. So it translates every number over 2 units. So that's one example of a translation. Another one would be where you actually subtract. So you could have g of x is equal to, say, x minus 3. So what would this do? This would translate to the left 3 units. So if we started here, then we'd move along the number line the other way. So these are examples of translations. We could also be thinking about what happens as a y-coordinate. It could be that we're actually affecting the y-coordinate, and in that case, vertically we would think about a translation upwards in the first case. So I put my number line vertically now, and in the other case, I would be moving down by 3 units. Okay, just a different way of thinking about it. This is where you have a horizontal line, and here's where you have vertical lines. Okay, what do we want to do with these is we want to understand what happens when we compose such functions with other functions, and how does the graph change? So let's look at an example. Here's a graph of a function f of x, and what we'd like to do is compose it with, say, g of x, and see what the new graph looks like. Suppose we know that g of x is like that original function we had, g of x is equal to x plus 2. Then f of g of x is simply f of x plus 2. Okay, so again, the question is, what is the graph of this, knowing what the graph of this is? Okay, well, in this case, what happens is we shift. This tells us to shift graph to the left by 2 units. So if you see a plus 2 here, you want to shift the original graph. So what do I mean by that? I just take this and I shift over by 2 units. So this is the new graph. But I've shifted, so now this is f of x plus 2. Okay, so see that this point gets shifted over to that by 2. This is shifted over by 2. This is shifted over by 2. This is everything's been shifted by 2 units to the left. Instead, let's look at a different example. Here we're going to look at what happens if we say take f of x minus 3. If you have a minus 3, this shifts graph 3 units to the right. Okay, so let's see what does that mean. Okay, there we go. That's shifted over to the right by 3 units. 1, 2, 3, 1, 2, 3. Everything's been shifted. So that's the graph of this function. Okay, so that's if we apply our g of x, our translation, to the x variable. What happens when we apply it to the y variable? Well, something completely different happens. What do I mean by this? If we take that function that we had before, say g of x is equal to x plus 2, and now we look at g of f of x, that's a different composition. That's the same as f of x plus 2. So here what is happening, we're taking the y variable, the f of x, and we're adding 2 to it. That means we translate in the vertical direction. So this is shift upwards 2 units. Okay, so I take my graph, and I copy it, I put it up 2 units, and my new function, f of x plus 2, is the graph of this new curve. Okay, lastly, we want to look at what happens when we subtract from the y value. That is, we look at something like f of x minus 3. So what happens in this case? Well, now in this case we subtract 3 units, so we shift down by 3 units. So we take our graph and we shift down. Okay, and so this is the graph now of f of x minus 3. Everything is down 3. 1, 2, 3, 1, 2, 3. Okay, this has been an introduction to seeing what happens when you compose functions and what happens to the graph.